Hey everyone, welcome to Data Engineering Launch. We'll give everyone another minute or so to file in and we'll get started here shortly. Music. Hello everyone, welcome to Data Engineers Launch number 75. Today's talk is going to be on real-time change data capture, CDC, processing and ingest into OLTP and OLAP databases. Today's guest speaker is going to be Eric Sammer, who's the CEO of Decodable. You can check out Decodable at decodable.co. This is Eric's second talk here at Data Engineers Launch. So if you're interested in the first talk where they covered the Decodable platform, feel free to check it out. It's available on our Data Engineers Launch playlist, as well as our YouTube channel in general. And I believe Decodable also has a YouTube channel, so don't forget to give them a subscribe as well. Co-organizers for this event are Rahul and myself. If you're interested in giving a talk here at Data Engineers Launch or our sister launch, Cassandra.Link, feel free to reach out to me. My email is listed below. Also, if you're interested in sponsoring, you can reach out to me as well. We're a part of Data Community DC. Data Community DC believes in building an inclusive environment, so no matter your race, gender, structure, and orientation, everyone is welcome, and we expect the respect to be given to all. Data Community DC is built of a bunch of different organizations. Data Engineers Launch falls under Data Wranglers DC, so if you're interested in all the various events hosted under the umbrella of Data Community DC, you can find out more at datacommunitydc.org. So what do we cover here at Data Engineers Launch? We cover everything from the ingress to egress of data, data wrangling, data cleaning, CDC, processing, OLAP, OLTP databases like we'll be talking about today. So if you're interested in anything, feel free to drop a comment or a question in the YouTube chat. If anyone's new here, say hi, hello in the YouTube chat. Group rules, if you have a question, ask it. Please drop it in the YouTube chat. We'll get Eric will be able to see it. Please do share what you know with us if you have any experience with any of the tools or topics that we're talking about today. Here at Anant, we design, build, and manage global real-time data analytics platforms surrounding Cassandra, Spark, and Kafka. So data engineering is a way of life for us. GW University helps provide venue space when we have in-person events. We also have some organizational and institutional sponsors. If anyone has any announcements, if they're looking for a job or offering any jobs or any meetups, hackathons, conferences, classes that they would like to promote, feel free to drop links and we'll get those transferred to and from. Anant is hiring full-time, part-time positions, data platform operators, engineers, architects. You can find out more at careers.anant.us. These events happen weekly on Mondays for data engineers lunches, and Cassandra lunches occur weekly on Thursdays. We've also released our 8th free Apache Cassandra runbook. The link is already in the YouTube live chat, so if you're interested, you can get it for free. This specific one covers high read and write latencies, as well as fixing large partitions for Cassandra. And with that, we'll go ahead and hand it over to our guest speaker for today, Eric Sammer.
Thanks so much. It's a real pleasure to be here with everybody today. I am going to share my screen just so we can sort of get going. I want to thank Anant and Arpan and the team for hosting today. We're going to talk today about. Let me actually grab my slides. Hold on one sec. We're actually going to talk about real-time processing of CDC data. Sorry, I can't do two things. I can't talk and move windows at the same time, apparently. So today we're going to talk about real-time processing of CDC data. I have a couple of slides, but as quickly as possible, what I want to do is jump into an actual demo and show you some hands-on processing and movement of change data capture data. So for those of you, and I think this group is pretty well versed in this, but just for anybody watching along at home, people say like, well, what exactly is CDC or change data capture data? It's basically just a stream of operations that were performed to one or more tables in a database system. And there are lots of database systems, including things like MySQL and Postgres and Oracle, but as well as, non-sort of SQL, non-relational database systems like Cassandra and so on that do support emitting change data capture streams. And when I say operations here, these are logical operations. They tend to be an insert was performed or an update or a delete, so on and so forth. So if you've never actually looked, and I know that the text here is a little bit small, I apologize for that. I kind of wanted to fit things. So basically, just to give you an example of what this winds up looking like, this is a couple of CDC events that you might see or things that would come out of CDC connector. So every CDC system does have its own formats and semantics and options and configuration information. There are things like Debezium, which is really popular. There's also commercial products that use CDC under the hood. There's things like HVR, which are recently acquired by Fivetran. So there's lots of systems like that that support these kinds of techniques. Debezium, super common. Its format is winding up becoming a de facto standard. I think lots of systems are starting to support Debezium's format. It's JSON rendering. So when we talk about sources and sinks, or source systems and destination systems, source systems generate CDC events, and then the sync systems interpret and apply those events to some in-memory state or some state that already exists. So in this example, for instance, just to give you a quick view of what this looks like, the operation here would be an insert, I for insert. The before record, in this instance, there is no before because we're doing a new insert. And then the after, this is what the record might look like, user ID 1, status active, and then I've omitted a bunch of metadata fields, but there's always information like the source system and, transaction information, LSNs, those kinds of things that you sort of really, commonly be able to find inside of CDC streams like this. Update events, which at least in Debezium are generally marked with a U. You get both the before record and the after record, assuming you've configured it, as such. And there are tons of configuration options with systems like Debezium and HVR. So the format you see might not look exactly like this, but you're going to have the same kind of data. And the reason why this is super useful is because you can understand not just that a change happened, but what that change is, what fields it was applied to, what kind of operation it is. And obviously you can find events like deletes. Many CDC systems also support the ability to put DDL change events into the stream as well, which is a little bit more advanced for a variety of reasons. I'm not going to go into a ton more detail of this. I really want to get into what can you actually do with this. So most of you probably know what CDC is, and why this is sort of interesting. It's kind of old hat. What I'm describing here is not anything sort of new. Most people wind up using change data capture data as part of database replication. And that is far and away the most common use case. Is just that I want all the, operations in database A to make their way into database B. And certainly you can do those kinds of things. That has plenty of use cases, especially going from operational systems to analytical systems, like your online production databases like Postgres and Oracle. And then maybe for data lake, data warehousing, you're using like Snowflake or Databricks. Totally common that you would use CDC data to get data from A to B. What I want to talk about today is some of the cool stuff you can do by processing CDC data rather than strictly being able to use it for replication purposes. So what are some of the things that you can do with it? So obviously, and I'm going to show you some examples of this in a sec. Some of the cool stuff that we've been able to see people using, and I'm going to show you some examples inside of Decodable today, but you can do this with lots of different systems. This isn't strictly a pitch on Decodable. Computing aggregate stats and derived views on data. So basically, you can process and transform CDC data in some systems. In this case, again, like I said, Decodable, we do this all the time. In addition to what you would normally think of as like event data, point in time data. And CDC data is a little bit more complicated because it has this notion of change built into it. One of the coolest examples of just really simple stuff you can do with CDC data is use it to detect when events have changed and fault and rebuild cache informations. And when you do this in real time, you can imagine really simple use cases of, I have user profile data inside of Postgres. I have a bunch of Redis caches that maintain sort of the current state of the user. You can actually use real-time systems to process that CDC data and be able to update those caches proactively, or even fault them, by deleting or clearing those caches and then rebuilding them with like read through queries and write back, those kinds of things, those kinds of techniques. You can also trigger external processes when a piece of data changes. So like a classic case might be a user updates their email address and you want to re-verify, maybe it's a B2C, application, you want to re-verify their email address. You can actually set up processes that look at the CDC stream and make a decision about when to do that, all without changing your application logic, because the processing happens on the replication log, or in this case, the CDC change stream that comes off the database. So the application developers actually don't even need to change that application logic. They can actually build this behind the scenes, which is super exciting. For a lot of correctness reasons, makes a lot of sense. The big thing that's worth pointing out with respect to CDC data is that transaction has already been committed inside of the database. So you don't have this double write problem where you want to update something in the database and then you want to perform an action. And if there's some kind of failure, you might make the write in the database and then not perform the action. Or if you do them in the other order, you might perform the action and then not actually be able to make the commit inside of the database. When you're operating on the CDC stream, you actually solve this problem, which is really, really cool, because you no longer have to worry about that. The database is able to interact with the application and sort of continue that transaction while backend processes can continue. So you can trigger various things, including kicking off, batch processes or making API calls to various internal services. One of the most common things I think we see is what I would call sort of looping through external services, whether those are custom microservices listening on like Kafka topics or Pulsar topics or SQS, whatever the case may be, and ML infrastructure for inference. So imagine you want to make user-facing product recommendations, and people are browsing your application. You have clickstream data coming in. You might take that clickstream data, join it with user profile data, and loop it through some kind of online model scoring or inference system that enriches that data with a set of recommendations or something like that. You can take the result of that and insert it back into the operational database to serve that back out through your application. And so insofar as people building application logic against the database are concerned, they make some updates inside of the database, and then another table in that same database just like magically gets updated at some later point. And so they can continue to build their business logic directly against systems like Postgres or MySQL or Mongo or Cassandra. And you can sort of enable all of this background processing by, like I said, what I would call looping through sort of these external services. If you are a B2B excuse me, service, you probably have this issue of providing like a data feed to your customers. You see this a lot in advertising and media, content distribution networks, CDNs and stuff like that. Always have to provide like access logs and that kind of information for analytics to customers. Excuse me, rather than trying to like batch all this stuff up, and which you can certainly do, you can actually give them a real-time feed that is sort of coming directly off of operational systems, which in certain cases can be incredibly high value. You've even seen some systems like Salesforce, for instance, start to offer what look like CDC streams so that you can take action when somebody updates like a deal or a customer prospect inside of Salesforce. You can actually operate on that change event. So the real cool part is that you can actually do all this stuff in real time, which allows you to build and extend all of the events that are happening in your operational databases to other microservices. So rather than just sort of talk about it, I actually want to show you some examples of what this looks like. So for this demo, I'm going to show you some stuff through Decodable, and I'm going to be using Postgres. And so you'll see me using Postgres inside of AWS. I'm actually using Aurora here. You can use lots of different systems, many of which support CDC streams, of data, but that's what I'll be using today. So just high level, I won't get into a ton of detail around Decodable, but just know that we have connections to source and sync systems, some of which support CDC, some of which don't. And then we have pipelines, which in the world of Decodable are actually just SQL queries. I'll show you that in a minute. That's what we're going to use to process this data. And so I have a CDC stream set up that is consuming data off of all changes off of a users table inside of Postgres. Let's take a quick look at what that table looks like. So I'm going to look at the users table, and you can see it's pretty simple. For the purposes of this demo, it's got a user ID, which is our primary key. It's a big int, a username, email, and status, which are varchars, some of which are knowable, some of which are not. And then I've added 2 timestamps here, a created date, which defaults to now, and an updated date, which the application logic would typically sort of, make sure that is kept up to date. So just to sort of show you that there's nothing up my sleeve, there's currently no records in this table, and our connection to this has the host name, which you can see is in AWS, port, database, username, the table that we're subscribing to, which in this case is the users table, and then many CDC systems and database systems have to have this agreement on sort of the encoding of the CDC stream. And so in this case, Postgres actually supports a number of different ways of encoding this information that have different sort of qualities to it. I'm using the default, which is called PG output. There's lots of details you can read about, from Postgres, but this is what the connection winds up looking like. And you can see that the schema here in Decodable matches or approximately matches my schema inside of Postgres. So we have all the same fields. In Decodable, I could use varchar. I use string because I'm lazy here. This is equivalent to the Postgres text type. So Decodable does some type mapping stuff, but for the most part, this looks and works the way you think it does. And so on the overview of this connection, we're connected to this Postgres information, this Postgres instance, and the output of this is going to what inside of Decodable, we call a stream. You can think about this as like a Kafka topic or a Red Panda Pulsar topic. It doesn't really matter. You can see that it's a change stream. So inside of Decodable, we know the difference between change streams and what we call append streams, which are basically immutable events. The difference being that we're going to receive a low-level CDC payload. Decodable actually understands how to treat this the same as if it were a record in the database. So there's some up-leveling of the event structure and the format that goes on here. And what I'm going to do is actually insert, some data here. So let me just make sure that I get this right. So users. So we're going to insert into users values 1. I'm going to be eSammer1. And I'll be eSammer +1 at decodable.co as my email address. And my status will be active, just making some stuff up. My created date is now, and my update date is now. So I've inserted this one record, and I have auto commit turned on inside of the shell. And so what you should see in just a sec here, the UI polls every once in a while, is that you'll see that we received a record. And if we look at the stream, it looks the way you think it does. What you'll see here inside of Decodable is that we have this key and we have a value. And you see that we've actually broken user ID out as the key. And the reason why the key is important is because what Decodable is going to do by marking this our primary key field is that it's going to partition the data such that all updates or all events, all change data capture events for our primary key are within one partition of our stream. And this is because we do parallel processing and stuff like that. And in systems like Kafka, you want to make sure that all of your CDC data is ordered by at least its primary key, so that you don't, for instance, process a delete before an update for the same primary key, or an update before a delete. So the order matters inside of this. So same rules around database replication and those kinds of things when you're operating with CDC data. So just to give ourselves a little bit of wiggle room, I'm going to insert another event that's going to be eSammer2 and for user ID number 2. And what we should see again here in just a sec is this data will pop up with another insert event. So this data will be basically, it's paused, sorry, play. So these are all of our events that are coming in, right? Not a huge surprise. You can sort of see all the same fields. This is user ID 2. Let's do something a little bit more interesting. Rather than insert, let's actually update users and set status equals inactive. I'm just making stuff up here. Where user ID equals 2. So basically, you're going to update one of our pre-existing records. And if we flip back over to Decodable, and I have to play this again. So what we'll see is another record here, again for user ID 2, that has all the same fields, but now status is inactive, right? Not particularly exciting, kind of works the way you think it does. What's the big deal? Okay, so the big deal here is we're actually going to create what we call pipeline. But like I said, there's lots of different ways that you can do this. And let's say, for instance, we want to create a count by user ID, group by user ID. So we want to count the user status by user ID. And in this instance, what's going to happen, whoops. Oh, my mistake, count by status. I'm going to process this. I'm going to start this preview data. And what's actually going to happen is this will retroactively process what's already there. We have one record that's inactive. We have one record that's active. Let's actually switch this user back to active. And what this should do is it will update in real time this group by. And this is because like Decodable is a stream processing engine, so it has all sorts of fanciness. But what you can see here is that we're not actually operating on low-level CDC data. We're treating this data as if it were data in this table. So I'm going to insert a new record here, eSAMR 3 that's active, and so this again should update to a count of 3. And if we again update user ID 2 to be inactive again, this again should decrement from the active and increment the inactive. And so basically this is effectively like a materialized table that's being built here on this change data capture information. So you can see that this is just one way in which you can process this data in real time, even though it's change data capture data. And so there's lots of cool stuff that you can do. You could write all this data back into something like Postgres or into the data warehouse to have like live reporting and those kinds of things and dashboards about sort of like what's going on inside of your application. So if we wanted to, we could call this the user status stats. And in the case of Decodable, this is going to create an output stream that has 2 columns, the status and the count. And you can see that we've inferred this schema from our query and all this other kind of good stuff. Decodable is going to ask you what the primary key should be. And the reason why this matters, again, for CDC data is that that's going to decide, which records, how records get updated. So for instance, if we pick the status, which is what we're going to do here, then Decodable is going to, whenever it gets a new value with the same status, it's going to update rather than insert. If we said count, which would be a little bit weird, it would actually update a record where the count is the same. Which would be sort of backwards from what we want for this stream. So we're going to say, we want status. So we're going to create our output stream for this. You can see that we update the schema to say that status is going to be our primary key. And we can name this pipeline user status counter. And now we have a new stream. So if I start this, and this is going to take a second to start, you can see its input is coming from that user's raw, which now has all of the updates that you saw me doing behind the scenes there. So see all the different updates that were happening, which comes from our Postgres user CDC stream, our total of 6 records that have come in. So we can sort of walk the lineage graph here in Decodable. We have our query. I'm trying to think if there's anything else we need to do. So unlike a connection, pipelines have both input records and output records. So we're gonna see these light up. And when you start a new pipeline on a change stream inside of Decodable, it will actually rewind and reprocess all of those events. So you can see that it just woke up and it went back to the beginning. It got 6 input events. It actually produced 9 output events because it's doing retraction, what we call retractions. And so if we look at the change stream here on the output side, you can actually see what's happening under the hood. So this is the wall clock time that Decodable saw when it was processing these records. It's just for debugging purposes. So you can see that initially the active, for key active, the count was 1. And even though these are split out into key and value, you can see that we didn't have to think about it that way when we were running our query. This is just how we organize the data under the hood. So you can see that we saw a couple of active users, our count goes up, our count then goes down, and then inactive goes up, so on and so forth. And then eventually you can see that there were no more records that were inactive. And so we actually, when we say null here, this is what's representing a delete. This is, again, what we call a retraction. So you're actually unwinding something that's already happened here. And then inactive went back to 1, and then active went to 2. And so just like we did before, we could say, for instance, let's make some stuff up. Let's say suspended, we suspend user ID. Let's suspend user ID 1. And so what should happen here is that suspended pops up as 1, and active also gets updated from 2 to 1. So you can see that this is the set of changes that are actually happening here. If we wanted to, we could write this data into a bunch of different places. The thing that I will say about change data capture data that is not immediately obvious is that because we're issuing changes and retractions to that data, the downstream system needs to understand these change events. In other words, if you have an immutable system, for instance, like, what's a good example? So do S3, you can't update records in S3. Once files are written, they're immutable. I mean, you can build systems that effectively allow you to update records by having tombstone markers and like writing retraction events and all these other kinds of things. But S3 itself is an immutable store. So if you try and pair a CDC stream with an immutable store in many cases, it won't make a ton of sense because the stream may want to make updates to records. Now, in the case of Decodable, we're reasonably smart enough to figure out, oh, you actually can't pair this. So if I tried to configure S3, the system would eventually stop me and tell me S3 doesn't support changes, doesn't support change events. The one thing you could do is you could write the actual stream of changes to something like S3 that does make sense, but you actually can't update records. So systems like Postgres, Redis, Rockset, I think StarTree even supports upserts these days. Druid, you can insert new events, but you can't modify existing ones. So for different kinds of systems, you may have to turn that change stream back into an immutable stream of data when you're processing it. It's a little bit more complicated, and I won't get into a ton of detail on that just yet, but just know that the target system is going to want to apply those changes. And so it kind of makes sense to write this data into systems that are immutable. And I actually see in the YouTube channel, we have a very special guest today. So Gunnar Morling is actually one of the original authors, if not the original author of Debezium. So the system that we're using here, Gunnar actually wrote the original version, or maybe even all versions of it. So make sure you say hi to Gunnar if you're in the live chat. He's a good guy. Thanks for joining, Gunnar. Really appreciate it. So there's tons of details on which systems support CDC and which systems don't and stuff like that. There's lots of information that's available out there. But this is just one example. If what we wanted to do, for instance, a really common case might be to like trigger alerts or something like that off of this data. So if we wanted to, let me show you just a quick example of what we could do here. So we have our user status stats. And even though we're seeing discrete events here, this actually acts like a table. So what I could do is I could create another pipeline here that basically looks for, let's say, where status is where count is greater than, I don't know, 10, or let's do something that's actually going to trigger, let's say 3. So this will basically output a record only when the count exceeds 3, and for a specific status. So what I'm going to do here is I'm going to switch my suspended user back to active, and I don't know that that will reach. Let's do this for user 2. Let's do this for user 3, just for giggles. This should actually, greater than 3. And let's actually insert a 4th user. So we hit our predicate. Let's see if my on-the-fly coding does what I expect it to do. It does. So here's an example of like effectively emitting an event. Now, if you had this go to a Kafka topic, you could, for instance, make some kind of API call, or open an incident in PagerDuty, or write something to Splunk or Datadog, those kinds of things. So lots of really, really cool examples of stuff that you can do. Now, because of my predicate, this, if I insert a 5th record, I think this will actually continue to trigger. So this might not be exactly what you want. What you'd probably want to do is turn this into a, a rate of change over time. I'm not going to spend the time doing that right now, but that's an example of what you could do. Anyway, so I'm going to stop this, and I'm going to check chat to see if there are any kinds of questions. Otherwise, and feel free to drop your questions in chat. I'll do my best to answer them. And Arpin, stop me if I run out of time. But
oh no, you got plenty of time. There is a question from Ann Vroom. Is there a role for this in cybersecurity, like changes as possible flag of intruder activity, and then also giving props for the presentation?
Yeah, no, I appreciate that. And you absolutely right. And without getting into a ton of detail, prior to starting to Decodable, I was a VP and distinguished engineer over at Splunk, which does a whole lot of stuff with time series event data and cybersecurity and those kinds of things. So yes, you could imagine, let's say, for instance, you had a click stream of all events from like an API server. You can then parse those events in real time, turn that into a time series where you count by CIDR block or by IP address or something like that. And once you see an unusually high number of requests from a particular client, for instance, you might temporarily insert like a security group rule that basically denies traffic from that particular IP address. So like that's like a super common, really simple to understand example of one of the places where you could use this kind of stuff. And I think we have another, Boyoung. Is there a specific configuration at the level of Postgres server or version needed for Decodable to be able to capture a stream? Yeah, and I think Gunnar actually answered this. So what we're actually using inside of Postgres specifically, and I'll show you this. Here's my pointer. There is a Postgres configuration variable called wall level, and this has to be set to logical. I think, like Gunnar said, it has to be, I think, Postgres version 10 or later, which is super old. So you're all going to be running something like 13 or 14, maybe 12. All of those should support this. And when you set up the connection, Decodable automatically uses Debezium. We're actually using Debezium under the hood. Decodable will use Debezium to like flip the right bits inside of Postgres to create what's called a production. And so productions from PG, let me see if I can remember this. No. what is it? There's a table that shows replication, origin, status, slots. So slots are subscriptions. So you can see this is actually what Decodable has created. So Decodable is actually consuming, information. But yeah, so Postgres creates a production which attaches a change stream to a table to a change stream and allows Decodable to be able to access it. In Aurora, AWS Aurora, there's some trickiness that you have to do with some special properties to emit a logical replication stream. If you search for AWS Aurora Postgres wall, wall status, is that what it was? Sorry, wall level. You'll actually see the help article about sort of how to enable this. Excuse me. So this winds up being database specific. So this is the place where you kind of have to check your database systems. But Oracle, MySQL, Postgres SQL Server, and Mongo, Cassandra, many systems support these kinds of logical write-ahead log streams that you can get access to. Could you do, Rahul asks, could you do this to aggregate updates from data coming from a NoSQL system? What Pinot or Star Tree allows us to do? Yeah, I mean, so whether or not you want to aggregate data pre-ingest or post-ingest is really going to depend on the particular application. So for instance, I don't necessarily think that this is like a replacement for Pinot or something like that. If you wanted to do aggregates specifically for to pre-aggregate something, you're not using Druid or Pinot or a system like that. And let's say, for instance, you want to report billing usage information to something like Stripe, or you want to write, daily, hourly roll-ups or something like that into a system like Postgres that might not be the best system to have, like, trillions or quadrillions per day, rows, records in a table. You could do those kinds of things there, but I don't necessarily think that. I mean, we don't take a religious position on whether you pre-aggregate, your data before writing it into a system, or do counts and aggregates inside of that system. Oh, Rahul asks, so send full records from, let's say, S3 to or Dynamo, and then to SQL running Flink, taking care of the aggregations. Yeah, you can absolutely do this, Rahul. That's exactly right. How invasive is, Benjamin asked, how invasive is CDC on the operational data store systems? Yeah, I mean, it can be. One trick, and basically the answer is it depends on the database system and sort of how they structure the write-ahead log and how they're able to produce these kinds of streams. But it basically is a full record of all changes that are happening to the database system. What you can do is set up a read replica whose sole purpose it is to sort of like generate this. And that's like the dirty trick to get around the overhead. Now, of course, the funny thing about that is in order to have a read replica, you have to have the write-ahead log, but like it's not as performance intrusive as a logical replication stream, which is what we're using here. Arpin, did you have any questions, or did anybody else in the YouTube chat have any questions?
Yeah, I have one. But to the people who are watching on YouTube, don't forget to drop any more questions or comments you have. But
yeah,
what you've shown here today, it's available via the free tier, right? On Decodable?
Yeah, that's right. So in Decodable, and I can give you some next steps on this. But if you go to decodable.co, you can create a what we call an account. We have a bunch of. I'm in a development region right now, but you can create an account. You can pick your cloud region, and we allow you up to 4 concurrent tasks. Where a task is, for instance, what you see here. So you can create up to 4 connectors or pipelines, some combination of those things, and be able to do this stuff today. So I strongly encourage you to try this at home.
Yeah, this is great. This is really cool to see. It doesn't look like any more questions in the YouTube chat. So if you have any wrap up, feel free. Otherwise,
yeah. So this is just a really high level example of some of the stuff that you can do with processing CDC data. And I think it's especially interesting when you pair it with real-time systems being able to create triggers, perform aggregations, or even just do database synchronization where you need to cleanse PII data and mask it for downstream users. It's also a really easy way of testing new database systems where you can actually bring up a consumer or multiple consumers that are running different configurations or even different database products, because systems like Decodable can have different source and destination systems. We handle those kinds of things. So we could have our source be Postgres and our destination be MySQL and do all sorts of like bake-offs and things like that, or even just span teams where people have picked different tech choices, different tech stacks. So there's lots of really, really powerful stuff that goes beyond just simple synchronization that you can do by processing CDC data in real time, which is super, super exciting. Including powering some of those other sort of new breed OLAP systems like Apache Pinot or Druid or Rockset, so on and so forth. So lots of really, really exciting stuff to do. Like Arpin mentioned before, where you can do this with Decodable today. Just go to decodable.co. You create a free account. There's ability to join our community Slack and stuff like that. I don't want to pitch that too hard. Otherwise, I just want to say thanks to everybody for all the great questions, and for Anant for hosting. It's always a lot of fun. Thank you all for letting me present today.
Yep. Thank you, everyone, for joining us here at Data Engineers Lunch. Again, thank you, Eric, for joining us. You're always welcome to give a talk. If you're watching this on YouTube, don't forget to like and subscribe and turn on the notification bell so you get notified wherever we go live or whenever we post a new video. Also, don't forget to give the Decodable YouTube channel a subscribe as well. And with that, we'll catch everyone next week.